Good morning, everyone. Today I want to talk to you guys a little bit about digital pins and more specifically buttons and pull-up resistors. So I've posted this web link in Classroom. I want you to go down through and read this in its entirety, but specifically I want to be talking about using pull-up resistors with pins configured as an input um, or as an input pull-up. So to this point, and I have shared this program with you and the simulation on Classroom as well. But to this point, we've been using switches like this. When I press the switch, it sets my button state to be 1. I have it set up in here so that if my button state is equal to high, I turn my LED on. Okay, and then when it's not on, my else statement, it's off. So click the button, it's on, let go of the button, it's off. So a couple of things here that we've been doing to this point is we've been using a 10 kilo ohm resistor, which you can see here, brown, black, orange, 10,000 kilo ohms, or 10,000 ohms, excuse me. That's connected to my ground terminal. That comes across to my button, and it comes across my button and into digital pin 2. On the opposite side of the switch, I have that connected to 5 volts. So when I press the button, that 5 volts comes across the switch, goes into pin 2, and then I'm turning my LED based upon that, okay? So when we're dealing with the program here, adding this extra resistor is really quite easy, but we can actually use this input pull-up and avoid using that resistor altogether. Okay, there's a 20,000 ohm pull-up resistor built into the ATmega chip, which is a chip that's inside of this. These pull-up resistors are accessed by setting the pin mode as an input underscore pull-up. Okay, and what's important here is that it inverts the behavior of an input mode where high is going to mean the sensor's off and low means that it's on. So currently, we are grounded normally. Okay, so remember this button switch is connected across these 2 points. So what we've been doing so far is what's called a pull down resistor. We're pulling down to ground. That is our normal position. So when we're not pressing this button, digital 2 is getting the ground signal from basically across this resistor. And then when we press the button, 5 volts can flow across, and instead of turning around and going back to ground this way, you have this big resistor in the way, it's going to come straight across to here. So again, that means that when we're not pressing something, our system reads 0, and when we press it, it reads 1. But when we do an internal pull-up, it's going to flip that around. When we press it, it's going to read 0, and when we don't press it, it's going to read 1. So let me just set this board up again for an internal pull-up, and then we will come back. Okay, so I just copied my program now, and I've changed the name of it to be internal pull-up, and we're just going to tweak a couple things. So first of all, with a pull-up resistor, the resistor that's necessary for the switch is just built right into the chip, actually, into like this part of the Arduino itself. So we don't need this resistor anymore, so I'm just going to delete that. Okay, and then the opposite side of this, because it's a pull up, it's going to automatically read 5 volts normally. So instead of connecting this to be 5 volts, I'm going to connect this to ground, and I'll change that to be a black wire. So if I went to go start my simulation now, and I go to press my button, nothing is really happening, okay? And you know, when I look at my serial monitor here and I press my button, nothing is happening because it's just getting ground no matter what. So what we actually need to do in here is just change a few things, okay? So for a pin mode, for a button pin, instead of it just being an input, it needs to be an input underscore, let me stop my simulation, input underscore pull up. Okay, just like it says right there. And Now if I start my simulation and I begin, notice that right now my button state is reading 1, it's reading high, even though I'm not touching it and my LED is on. So when I press the button now, you can see down in my serial monitor that now button state is equal to 0, the LED is off, and things are happening. Okay, so again, a pull up defaults to high, defaults to 1, a pull down defaults to low. And again, high, 5 volts, low, 0 volts makes sense, okay? So in this case, I really want my LED to be on when I'm pressing my button, not when I'm not pressing my button. So like that's a simple thing of just changing if button state is equal to, let me stop my simulation again, is set to low. All right, so if button state is equal to low, okay, so the button has not been pressed. Or no, when the button has, no, that's right, when the button has been pressed because it sets to low. So we can start the simulation now. Okay, so now I press my button, my LED turns on, but notice that my button state is low, right? So again, if button state is equal to low, which it currently is, LED pin is going to be high. My else statement, is just the opposite of this. If button state is equal to high, which it currently is, then digitally write it low, right? So the else is the opposite of the if. Here the if says if it's equal to low, so the else must be if it's equal to high. Couple other things that I've done in here that are different or slightly different than we've done in the past is for button state, I've actually set this up as a Boolean. Okay, and again, this is a variable, it's going to change. We can use that for storing values like the state of the button, for instance. So we can use Boolean as a button state because there are only two separate options for it. Okay, it's either going to be off or on, right? It's either going to be 0 or a 1. So a Boolean, which is similar to an integer, but again, an integer carries, can't exactly remember what an integer carries right now. It's like 32,000 or 64,000 values, something like that. The Boolean only carries 2. Okay, it's either 0 or 1, nothing in between. So we can actually check how many variables an integer has here in the Arduino website. So if we go up to the resources and we go down to reference, this is all the language reference stuff that's associated with Arduino. So you can like start looking at this and doing some self-discovery here, things like pin mode, digital read, digital write. But down below here are variables, okay? And again, the variable that we're looking for right now is a data type. It's an integer. So an integer, yeah, so here we go. On an Uno, an integer stores 16-bit value. So that goes from negative, roughly 33,000 to positive 33,000. Okay, so again, it's like 66,000 different variables where when we look at like a Boolean, for instance, a Boolean is just going to be able to carry a 1 or a 0. And it's interesting too, it's recommended to use the standard type bool, which is identical. So a bool holds two values, true or false. Okay, so according to this, it's not supposed to be a Boolean anymore. It's just supposed to be a bool. I never knew that. That's something new. So when we come into here, we can remove that and I guess just set that up as a bool. And when we start the system, operates the exact same way. All right, so a couple different things to look at for today. This is more for self-discovery. This will also make wiring a lot easier when we come back to school using an internal pull-up. But realistically, the thing that you guys should be pulling from this is A, how to be able to set up a pull-up, go through the code, And understand that a pull-up is going to normally read high, and when we press it, it's going to read low, while a pull down normally reads low, and when we press it, it reads high. Those are the main goals for today. Okay? Have a great day. We'll talk to you soon. Email me if you have any questions. Bye-bye.